Okay, I see. Okay. Yeah, the question that your friend asked is when they extract the features, I mean the words from the training dataset, the Weka will, for example, extract bunch of features, bunch of words, but when do the same on the test dataset, they will get another different kind of feature set, different kind of words. So when they train their model on the training dataset, they are not able to run that trained model on the test dataset because the input is different. The feature sets of the training data, which are the input to the model, are different from the input to the feature set of the test dataset. So yeah, so to solve it, I recommend you sorry. Yeah, this is the data that you have. You have the test data, and you have a train data, which is bigger. We have two phases. The first one is feature extraction. And the second one is the training. And the third one is to apply on the test data. In feature extraction, if you are using Weka, you should use a string to vector, yeah? A string to vector, to word vectors. I mean, for the first phase, the way you can do is to, you have the train test, you can append the test data set to that one. You can search on Google how to append two CSV files together. You can do it in Python, or you can do it manually by opening this training data set and then manually copy the test data at the end of that and then save it as another file, which now is a big file. Then give it to the Weka and apply that method, a string to word, and then you will get this data that the columns are the features, the words that are extracted. And then you will split this one again to two files, which is your training file, and then your test file, training, testing. Now, if you do that, now the columns of both training and test file are the same. These guys are the same. So for the second phase, you can load this file to your model. Let me call it train2, test2. You can load train2 and then use your classification algorithm, train a classification algorithm, and then apply that algorithm on the test data to see how it is working. If you guys are working with Weka, this is the way that you can do. I think it's straightforward. If you are using Python programming language, you don't face with this problem. For example, one of the libraries in Python that you can use is scikit-learn. If you are extracting TF-IDF, just search TF-IDF in yeah, scikit-learn, and oh, okay, let me get rid of, yeah. Sorry for this. Yeah,
And
if
we have to
if
do
you are
all
going
When
to
you
use it,
converted the string to Word, then how do you split it into train and test?
sorry.
So how do you split the? So after feature extraction, how do you split it into train 2 and test 2?
This guy, so you can use it, man. You know that, for example, until this, for example, the number of the rows is 15,000.
Okay. Okay,
Yeah,
that makes sense. Oh, okay,
yeah.
okay.
Because
So
backup will
basically, I can do
not.
it like manually.
Yeah, because backup will not reorder them. Yeah, so the order are the
Okay,
same.
okay, that makes sense. Okay.
Yeah.
my question is that we have to do all of this before any pre-processing, like before smooth, before stemming and word selection and stop word removal.
Yeah,
Or-
when you apply this function, you can do the stemming or stop words removal, whatever you want. And then based on those options that you select, it will give you a bunch of features.
No, I mean combining the test and training set. We have to do that before we do any
Yeah.
pre-processing.
Yes. Yes. You combine them together, make a big file. But I'm telling you, if you are going, sorry, I don't know how to remove these guys. Let me, yeah, okay.
For me, what I'm kind of wondering.
If you are using, for example, Python, in Python you have TF-IDF, you have a library scikit-learn, and through that you can use TF-IDF. If you do this in this way, you will create a TF-IDF, and then this TF-IDF model, you can give the test data to this model, and then it will generate those features for the test data set as well. So you don't have this problem that we have here. But in Veka, if you are going to do all the things in Veka, this is the way that came to my mind. Yeah.
Okay.
So can we not use Weka at all? Can we just use Python, like for everything?
Yeah, you can use Python for everything. And I think if you are not familiar with that, at the beginning it's a little bit hard, but there are lots of bunch of samples on the internet. You can search and see how they are doing. But if you are not, if you don't like to go through those things, to spend time to learn those things, or you have some time limitations, you have other, you have the deadline is, when is the deadline for the project?
April 6th.
Yeah, the deadline is near, and you have other courses as well. So you can go through Veka, but if you are familiar with Python and you have worked with those scikit-learn library stuff like that before, so it is in this case it is more straightforward for you to use Python, because in Python when you wrote your code, if you want to apply another classification method, you just change the classification for them. Then you can reuse all your previous steps and run it, and all the works will be done automatically again. But in Veka, if you should do lots of things manually by yourself. But the good thing is that you don't need to program. It is just you can do all the works via GUI, like using the wizards and just next, and then it will happen. It depends on you and how much time do you have and how you are interested in each of these ways.
Okay.
Okay, so we're not going to be penalized for not using Weka, right?
I mean, it depends on you. You can whether use Weka or Python or any other programming language is different from different person. It's based on their background, whether they are familiar with using those things or not. Yeah.
Okay. Thank you.
All right. Actually, my question is, okay, so let's say we split into TR2 and TE2. For me, what I'm wondering is that, like, does this kind of change it up a bit in the sense that what I'm thinking right now is that, like, in this case, or how can I put this? Like, I mean, the whole goal for us is to predict, like, whether a sentence expresses like a positive sentiment, a negative sentiment. But if we have the data like parsed like that, then are we just going from checking whether like a sentence is positive or negative to whether a word means like whether a word expresses a positive or negative sentiment?
I'm not sure whether I got your question correctly or not. You mean you are in the input of your for the input of the model, you have just words and you are concerned whether it is enough to determine whether that sentence was positive or negative?
Yes, pretty much, because like if the test, because if how can I put this? Like the test set, like the original test set that we're supposed to be using consists of sentences, right?
Yeah.
So like if like we go from making a model based off of words to testing it on, I guess like my point is that like shouldn't it be that like we make a training model based on like sentences and maybe somewhere under the hood you kind of parse it into words and whatnot, but at the end of the day you end up with a model that is checking sentences versus here where you're making a model based off of words, but now you're using that to test a sentence which contains one or more words.
Yeah. Yeah. Dealing with text data in traditional way, for example, you have the text data, the document. In document classification task, you have text data, which we call it document, and your task is to determine which classes it belongs. That in your case, we have 3 classes.
Like
your models need inputs. Yeah. So one of the way to give these documents to the models is to extract features from these documents. The document can be whether a sentence, can be a paragraph, can be a large text document. In your case, it's just a sentence. And one of the traditional way to extract features from the documents is using the bag of word models, TF-IDF. These are the traditional way to do that, but still they are very strong and they have very good accuracy, especially for the data sets that are not much big. They are small. So it's because of their strength, they are still getting used. And in these models, we convert the sentence to bag of to just mention which words are appeared in this sentence, whether, for example, word 1 appeared to this sentence. If it doesn't, you put 0. If word 2 is appeared, you put the value. The value, if you are using bag of words, you may just indicate whether it is appeared or not. Or if you are using TF-IDF, you put the TF-IDF score. So you will create these guys as input features. Is it good? it is good in a way that it is determined which words are mentioned in this sentence and which words not. So you can use these guys to differentiate sentence together, because each sentence is a combination of the words, and the words are different. The words that are mentioned in that sentence are different from the words that mentioned in other sentences. So this kind of model, feature extraction model, can be used to differentiate between the sentences, and this is what you need. This is what your model needs to classify them, because it should determine the it should be enabled, we should be able to recognize each sentence from each, to differentiate between sentences together. But it has some weaknesses as well, which in sentence you have a sequence of words. For example, the word to is appeared after the word, for example, 99, and after word to is the word, for example, 20 is appeared. So you have the order, but in this model you ignore the orders. You don't keep the orders anymore. So new feature extraction models from the text data appeared, especially for the deep learning model, that they use, for example, recurrent neural networks. Using the recurrent neural networks, they will enable you, they will give you some bunch of features. They will convert the text document to bunch of features for you. The features are not like this, that, for example, it mentioned that word one, what is the score for word one? It has, imagine you determine the output should be 200. It is 200 boxes that has some numeric value, but without any meanings. It's not about the word or something like that. It's just a vector of numeric values. But it can be used as a representation of that document. So in this way, they consider the order of the words in the document as well, because it gets word by word from the document. And for example, when you give the first word goes in, and then the output of the first word will go as the input, and then you give the second word as well. And then the second word and the output of the first word will go into it, and then create the output of the second word. Then you will give the third word. The third word and the output of the second word will go as an input to the model again. And so it will consider the order of the words in the document as well, and will generate a representation, a numeric vectors that can be used as a representation of the document. It has some advantage and disadvantage. The advantage is that you are considering the order of the words as well. The representation model is more packed than the bag of word models, because in this model you have lots of words, for example, 10,000 words. It's a big vector and a sparse vector. But here is a dense vector and more compact, and also consider the order of the words. But the problem is it needs a huge volume of data. You should have a huge volume of trained data to create that. Otherwise, it won't be able to give you a good representation. And the other way that is very famous is use the pre-trained model. Using the pre-trained model, they can be useful for your project, I think, like the models that are trained on a very huge volume of data. And then you can use those models for your task. They are called transfer learning as well, that you train a model on a task that you have a huge volume of data, and then apply that model on a small volume of data. But if you are not familiar with these models, don't go for that. It took time to get familiar with these kind of things. and you don't have time for that. But you are using this way, and it's a traditional way, but don't underestimate it, because still it is very strong, and in so many applications it is so competitive against these two models, and sometimes it's better, it's working better as well. Yeah.
Okay, I mean, I assume that like with everything in mind, the test set has to be made up of multiple. I mean, when I say how do you put this? The test set, like, because the training set, I mean, the training model was essentially trained on a big set of word attributes, which means that the test set also has to be made up of a set of word attributes.
Yeah.
Because if you don't do it, if the test set is not made up of word attributes, and you end up with the issue that Soo-Young Kim mentioned, where the training set and the test set are not compatible. Because and with that in mind, I tried doing an alternative, which was you use a filter classifier, but within the filtered classifier is where you apply all the set of filters you need, if you understand what I mean.
I'm trying to make it. Oh, okay. Sorry.
I
Yeah.
mean,
I think he's back to the same question of like combining both the training and testing and choosing the attributes, because he's doing all the training alone and then he's putting it on the testing.
Yeah.
Right?
Yeah, I think so. This is what I inferred. Yeah. Is this your question?
yeah, it's just I want to know, like, because there was a way you explained it, but then when I tried, I mean, there was an approach that you gave, but like when I tried doing that, I end up with errors basically. So I also just want to like validate also, like, I guess I found this other approach online. That one was just using the filter classifier, but you do not do any like data pre-processing, in the sense that you don't use string to vector right before you actually train it. Within the filter classifier, you can have you choose all of the filters that you need. So string to word, if you need to take a subsample, then you do that. If you need to use smoke, you use that. And then like I guess my point is that you do everything in one shot instead of just you pre-process first,
Yes.
and then you start. It's like within the whole like training process, you do all the pre-processing and whatnot. Is that okay as well? Because when I do that, then I don't run into any train set and test that are incompatible issues.
Yeah, I mean, this is the way that came to my mind, but the weakness is that, yeah, you pre-process your data first, and then you are going to use that pre-processed data to compare different models, which one is better. But if you want to change in your pre-processing again, so you should come back and then apply it on the both test and train data set together, and then split them again to train and test, and then apply it, and then figure out how your classification models are working.
Okay.
I have a
Yes.
Yeah, okay. I have a question regarding the distribution of the data. You see some of the classes have more instances than others. I know there's a method we can use, it's SMOTE, it's a synthetic. Should we do that before or after we do all the stemming and subword removal and attribute selection? Does it matter? Because I mean, if we're creating more instances, then that could affect the attribute selection and or stemming. I was thinking maybe do
What does a smoke do?
Pardon?
What does a smoke do?
It creates more instances, synthetic instances of the class with less attributes. So the distribution would be similar at the end. So let's say you have two classes, class 1 and class 2, and class 1 has 10 instances, and class 2
Yeah.
has 5, then it doubles it with fake attributes, fake values, I guess.
Oh, okay. In this case, I think when you combine the test and train together and then extracted features and then split them again to train and test. Now do the smoke. Is this the correct?
Yeah.
Then apply smoke on these guys and make it bigger, and then train your model, and then apply this test set on the train model, to see.
Okay, so the stopword removal and stemming should be done in the entire combined
Yeah.
file, and
Yeah.
this mode separately. Okay.
And then when you got this training data set, you can do whatever you want with this train data.
Yeah. Okay. Oh God, I have to repeat what I did. It's
I have
very
problem
long.
with
It takes
this.
so.
Oh, okay, I found it.
It takes
I
a
was
very
looking for
long
this.
time to finish the process because of the large data set.
Yeah, pre-processing is very important. If you don't extract good features from your data, whatever models that you are using, they are not able to have a good accuracy. The most important one is what kind of features you are finding from this. And when you, yeah, I think it's good to spend some time to find an optimum value of the words, whether it's better to use TF-IDF or just bag of words, whether it is good to stem your data. But generally, stemming the data will increase the accuracy of your classification algorithms. It is not something that always 100% for all the kind of data, but generally in majority of the data set, when you do a stemming, it will increase the accuracy, the performance of our models, because the variety of the words will be diminished because,
Yeah.
for example, you have word works or worked, working. You have different variations of the work, and stemming will convert all of them to the root, that is work.
Yeah.
So the number of the words that are used in your test or training dataset will be reduced, and it will help your model because the complexity of the data will be reduced. So stemming is a good approach to do that, and also removing stop words is a good way as well, because those stop words are used in all the documents, so they cannot be as a good indicator to differentiate between the documents. So those are the things that you can do, and also you can, for example, the number of all the words that you use in your document is 10,000. But if you want to keep all of them, it makes this table so big, has 10,000 columns. Then in the training of the models, you will face with problems as in terms of the time that took your model will be trained. So it's good to reduce this size as well. For example, to keep the these are the numbers that I'm just mentioning. Maybe you should find the optimal value yourself. For example, maybe just keeping the 1,000 is better, or 500 is better, or maybe 100 is better. Yeah, these are the things that you should test it yourself. And also the data set that you have you have some punctuation marks like dot, like comma, like semicolon. Maybe it's better to get rid of all of them, or maybe keeping them is good, or yeah, or just removing all the characters except the alphanumeric, or maybe the numbers are not useful as well. Just keep the characters like that and ignore all the characters that you have in your test and training data set, and then just keep these guys. It will make your data more clear.
Does it matter if we use Porter or not? I know the professor.
Porter is a kind of stemmer.
Yeah.
There are some bunch of stemmer algorithms as well. So from my point of view, it doesn't matter. All of them will do the stemming for you. Yeah.
Okay. And one question. My partner tried neural networks, and my connection is unstable. Can you hear me? Or
Yeah, I can hear you.
okay. Yeah, he tried neural networks, and he's saying that he's getting more instances than other methods. I don't know if this is even possible, but that's what's happening.
More. What does he mean by more instances? As an
He's saying,
output of the neural net, when he wants to classify the test data set.
oh, sorry, there's more neutral instances than positive and negative.
I don't think so, because because the neural network. Okay, create a new one.
And it took him like 2
Yeah,
days for the thing to run.
The neural network is like that. You have input layer, you have bunch of hidden layers, and then at the end you have an output layer.
Yeah.
The input layer will be determined as the number of the input features. In your case, if you are using word to vectors, if you determine, for example, the number of the words is 500, so it will be 500 nodes here. Hidden layers, it depends on you what kind of structures are you using. You determine that. The output layer is equal to the number of the classes. And if you have 3 classes, so it will be 3. And yeah, these guys are hidden layers. So these 2 guys are determined based on the data that you have, which the input depends on the number of the input features. The output is determined based on the number of the classes. So it should have just 3 classes. Otherwise, maybe he adds some more classes as well. For example, put the question marks for the class. Yeah,
No, he didn't add anything. He's just saying that he gets more neutral instances than other classification methods. Like he's getting a lot of neutral ones than negative and positive.
Yeah, maybe he appended the test data to the training data set and put some, for example, question marks, because in your test data you don't have class labels. So maybe he put some something to fill those classes, and now when he trained on both of them, he have more than 3 classes. So this came to my mind, but it shouldn't be happen.
Okay.
Hello, sir. Can you hear me, sir?
Yes.
I came a little bit late. So you mentioned after combine like to the training set and the testing set, and you do some like feature selection. Like what kind of step like we need to do for that part, like for the feature selection?
Yeah, when you are using, do you use Veka?
Yes.
Yeah, in Veka, you are using a string to word, and in a string to word, you either can use the backup word models, or you can use the TF-IDF or just temp frequency. And also, you can do some pre-processing on your text data using whether to use STMR or not, or whether you remove the stop words or not. Yeah, stuff like that.
Oh, okay, okay. Thank you.
Yeah, yeah, like. Um, so the deadline is April 6th.
Yeah.
Yeah, just 9 days. Is it enough for you guys?
I mean, honestly, it's just every single thing is taking very long to finish, like the pre-processing, and it's not too complex, but if we don't get something right, then we have to repeat the entire method, and it's taking way too long to finish. Like especially, for example, Smote, like it's taken almost 2 days, and now I have to repeat it because I have to combine the data. So I don't know, honestly.
Yeah. Do you guys have a forum for yourself that you can have access to your friends as well? You are using Moodle, yeah? In Moodle, do you have these kind of things that?
Oh,
all the
discussion
students-
forum?
Yeah.
We don't have one for this course.
Yeah, but I think this kind of thing can be helpful because you guys are working on the same data set, and maybe the question of one of you was the question for another one as well. And you can maybe get help from each other for those things. But yeah, the time is so limited, and
Look, I started
but
the next day.
using Veka is straightforward, and I hope you guys can do a great job and get a good mark. But you should provide a report as well, yeah?
Yeah.
Yeah, Professor will read the report herself, so I think that the report has mark as well. So put some time for writing a good report as well, to provide some, if you can provide some statistics about the data, some charts, stuff like that, that could maybe can help to enrich your report as well.
Yeah. When are we going to get our marks for the assignments?
I just finished the programming part of the assignment 2, and the other questions of assignment 2 still remain, and assignment 3 completely remain, but we are making a solution for the assignment 3, and it will be accessible for you guys. If you need the you received the solution for assignment 2, yeah?
Yeah.
If you guys think that the solutions can be helpful for your project, we are making the solution for assignment 3 as well, so you can have access to that. But the marking, I'm trying my best to finish that, but it's a little bit harder right now because in the past we print the assignments and then mark on paper. It was easier. Now I should do it on the PDF file. It's a little bit slower, but I hope I can finish it.
Okay. Thank you.
Did you say before April 5th is a possibility? I mean, the thing is that because we have an exam coming up, so I mean, we won't know if we did something wrong or right, and whether we have to work harder, study harder, and whatnot.
You mean the extension for the project?
No, I mean, like, is it possible to get our marks back for assignment 2 and assignment 3 before April the 5th because we have an exam on April the 16th, right?
Yeah. Oh, you need that grades to figure it out whether to drop the course or something like that.
That as well.
Okay. I will try my best to give you guys to give
And
the ones. Yeah.
there is actually
But usually the assignments has a low portion of your marks, of your entire marks. Yeah.
Assignment 3 was pretty high, and I don't think I did well on the last question.
I think the majority of the grade depends on the project and also the final exam, and then after that midterm, and after that assignments. So assignments has a very small portion of your grade.
Yeah.
Hello.
Hello.
Oh, okay. I still don't understand how could we transfer the word predict result to the sentence predict result. So could you explain a little about that?
Sorry, would you please repeat your questions? Sorry. Can you please ask your question again?
Oh yes, because when we train the model and after that we predict the result based on our model, then we can get the result based on the different words. So, but for the project, we are asking for the prediction for the sentences. So how could we transfer the word predict result to the sentences predict result? I don't understand that step.
I didn't get your question.
Oh,
I'm sorry.
I think it's again on the test and train combining them.
You mean you combine the test and terrain together?
No, she's saying she's having problems predicting after she does the training on the word, on like the training set, right?
Oh, okay. You convert the training file to the words using a string to words. Do you do that?
yes, I've done
And then-
that. I mean, after I'm predictions. So
Yeah,
I've got a lot of words with if it is the negative, the neutral, or the positive. But the question is, how can we transfer that the words prediction to the sentences prediction? Because we need to predict if a sentence is the positive, negative, or neutral. It's not just the words, right?
Yeah, we talk about that. It was a question of your friends as well. Yeah, in document classification, you have a bunch of documents which they consist of some sentences, words, and stuff like that. In your case, you just have a sentence, and you have a classification model. In order that model can be able to classify these sentences, you need features. And so you should do the feature extraction. And one of the way to do feature extraction is the bag of words model, that they will convert these sentences to the words that was used in the whole entire corpus, in the whole entire data set. And they will determine whether, for example, this word is used in this sentence or not. If it didn't, you put 0. If for example, word second is used in this sentence, you put 1. This is the bag of word model. And then you can use this guy as a feature to train your model. It's different from the sentence, I agree, but it's a way to represent the sentence. The problem that these models cannot handle sentences because sentences have different lengths. You have a sentence, for example, the sentence one, the data sample one, the length is, for example, 100. It consists of 100 tokens or words. Sentence two, it may consist just 20 words. Sentence tree may just consist 300 words, or the other one maybe 5,000 words. So because the length of the input data is different, because the length of the input data is different, so you can not train lots of models on them. Lots of models, they need the input of the model as a fixed length for all the samples. So one way, by extracting bag of words model, you are converting all of these guys to the fixed length. If you determine, for example, just keep 500 words in the setting of the string to words, all of these guys, variable length input that you have, all of them will be converted to the fixed length. Then your model will be able to be trained on these guys because all of them has a fixed length, which you couldn't do it on these guys because they are different in the length, and your model needs to specify the number of the input features. So you have to convert them to different kind of representation, which one of them is in this way that you are doing. If you just mention whether this word is appeared in the sentence or not, you are using the bag of word models. If you are using TF-IDF, the structure is the same, just the value of these guys are different. 0 for the words that are not used, that is for the words that are not mentioned in the sentence, and numeric value for the words that exist in this document. And this guy is in the range of, I think, 0 to 1. The more shows, the more this word is important in terms of recognizing this document. That's it.
Even the testing data, we're changing the sentences to words.
Yes.
That's what we do when we combine it, right?
Yeah, you have to. Yeah.
But does that not we're like testing whether words have a sentiment, not whether a sentence, we're testing the sentiment of a word, not a sentiment of a sentence, right?
Yes, because you convert the sentence to this model and use this to classify this sentence, actually. That you are using this representation to determine whether this sentence is negative or positive.
But if the test set is being converted to a word, now we're like testing whether we're predicting the sentiment of a word, not a sentence, right? Because
combination of the words, not just the word, combination of the words. Each sentence contains some words, and now you are mentioning here which kind of words are used in this sentence. So you are considering if these kind of words appear together, whether they can be positive or negative or something else.
But then let's just say, I created my model and then I load it and then I load the test set. Then I guess, is there something that kind of happens that I guess understands that the test set is made up of if the test set is made up of text attributes, and so maybe it automatically converts that test set from text attributes to word attributes, and then it will check.
This is the thing that you are doing. Yeah, you are converting the test data set to the words as well. You should treat the test data set exactly the same that you treated the training data set.
Because the thing is that, for example, let's say if I trained a model using if I train a model using like discretization, and so now all the attributes are nominal, right? But the way it sounds right now is that I can use that training set, I can use that trained model that was trained using nominal attributes, and I can use it to test, and I can test it on a data set containing numeric attributes.
You can do it, but
That's kind of
because
what's going on. That's
because
what we're
in
having
this
right
way
here now, basically.
you
Like the
can do
same
it.
idea.
You can do it, but in the problem is in this way, if you treat your training data and test data in different way, so they will be different. So the distribution of the training data will be different from the distribution of the test data. So the model that you train on that training data could not have good performance on the test data because you are testing it on a data set that has a different distribution. So you should, whatever approach you are using for pre-processing the training data, do it on the test data as well.
But then, I mean, for
yeah.
example, if like the test data itself, I believe has about at least 14,000 tuples. But and
14,000, yeah, tuples, yeah.
so if I was to apply the string toward vector over there, there's one thing for sure, and that's that like we will end up with a test set that has probably, I don't know, maybe 50,000 tuples instead, because we just split up text into a bunch of words. Is that what we're supposed to be doing?
This is your test data, yeah? It has 14K samples, yeah?
Yeah, but if we use string to word vector, does it not convert each word in there into individual attributes? So if you have let's say you have one text tuple, and the text says I like pie, so I'm supposed to be testing the sentiments about. I'm supposed to be testing the sentiment of a text of like a piece of text, one tuple, but then if the training model was like trained like with string to word vector and whatnot, then and if I have to apply the same thing to my test model, now what I'm doing is I'm splitting that text, I'm splitting that one tuple, which is made up of one attribute, into 3 tuples, and there are also 3 attributes: I, like, and pi. So we're supposed to be testing it like that. But then if we're testing it like that, then how is that predicting a sentence? We're just predicting a word, basically.
This is your test, and then by string to word, you will convert it to this one, yeah? This one was a sentence, and now you have a bunch of words, yeah?
Like we have a bunch of words, but if we are like, if we're like testing, like if we're applying the same data processing stuff to the test set that we did to the training set, then wouldn't we just be predicting whether a word is positive, negative, or neutral versus whether text is positive, negative, or neutral? Like for instance, we have like, I guess in the diagram that you're showing right below, you have, let's say, one tuple over there. So now we went from
What do you mean by tuple? You mean columns or the rows?
I mean like the rows.
Okay,
Sorry.
the rows you call, okay.
Because like on the left hand you have one like text tuple, and you're essentially like predicting whether that text tuple is positive, negative, or neutral.
Yes.
But then when you break it down using string to word,
yeah, it's still it's one tuple.
Tuples instead.
It's still one tuple.
What am I saying?
No, it's still one tuple.
Still one. Okay.
Yeah, but you have more columns. This one was just one column. Your input data consists just one column, but now you have more columns, more features. Yeah, you converted this text to, for example, 500 features. Yeah, it is still one tuple.
Okay. And obviously, like we're getting all of that thing from if we were to combine the training set and test set together, and then, like you said, we just partition, like either we can like manually partition out the test set.
Yes.
Okay. I think I get it. Okay. Thank you.
You're welcome. Any questions?
Yeah, I have a question.
Sorry?
I have a question.
Okay, yeah, go ahead.
When we're doing data pre-processing, can we do lemmatization instead of stemming?
Yes, you can do it. Yeah.
Okay, all right. Yeah, that's my question. Thanks.
Does string to word have lemmatization as well?
The one?
Are you using a string to words in Bekan?
No, I was going to do lemmatization in my Python program, but we could use it.
Okay, yeah. You are free to whatever you are going to do. Yeah, lemmatization is good as well.
Okay, all right. Thank you.
You're welcome. Okay, guys. I hope we reached to 3 p.m. I hope you guys have a good Friday, and also good luck with the projects and other exams that you have.
Thank you.
Yeah. Okay.
Yeah.
And I think if when I leave the chat, I will be able to save the recording. I have not yet done that before, but I think after I'm leaving, I can save it, and then I will give you guys the access to that.
Yeah, I don't know how it works, but I know some of the props had issues and the recording got lost. So.
Oh, that the previous recording is lost?
No, another professor in another course had that issue, so I don't know how to do it.
Oh, okay. I hope it won't be that.
Yeah.
Okay, good luck.
Thank you.
Have a good Friday. Bye-bye.